Modernage MCQs Physics first year, unit number 7, Oscillation, part number 3. A block of mass m is suspended with a spring of spring constant k. The spring extension, option A, x is proportional to 1 by m, B, x is proportional to 1 by g, option C, x is proportional to 1 by k, option D, x is proportional to k. The key is x is inversely proportional to k. The correct option is C. Reason. Formula. F is equal to kx, where F is the applied force, k is the spring constant, x is the extension in the spring. When a block is suspended with the spring, F is equal to the weight of the block, which is equal to mg, or we can write this as mg is equal to kx, or x is equal to mg divided by k, or x is inversely proportional to k, because the mass of the body is constant and g is constant for the given place. Therefore, mg is equal to constant. Hence, the spring extension x is proportional to 1 by k. The amplitude of simple harmonic motion oscillations with the passage of time, option A increases, option B decreases, option C remains constant, option D becomes 0. The key is remains constant. Therefore, the correct option C. Reason. In simple harmonic motion, the frictional forces are 0. Therefore, there is no dissipation of energy. The total energy of oscillation is Et is equal to 1 by 2 k x naught square, where k is the spring constant, x naught is the amplitude, or x naught square is equal to 2 Et divided by k, or we can write this as x naught is equal to 2 Et divided by k square root, which is equal to constant, because the total energy is constant and k is the constant. Hence, the amplitude of oscillations remains constant. In simple harmonic motion, the time period of a body of mass m oscillating with frequency f under restoring force F having total energy E does not depend on option A, mass m, option B, frequency F, option C, force F, option D, energy E. The key is energy E. Therefore, the correct option is D. Reason. Formula. Time period T is equal to 2 pi into square root m divided by k, which means that the time period depends upon the mass of the body and spring constant, and it also depends upon the frequency, because T is 1 divided by F. The total energy E is equal to 1 by 2 k x naught square. The time period does not depend upon the amplitude of oscillation, because x naught is constant, k is constant. Therefore, E is constant at every instant of oscillation of body, because x naught is constant and k is also constant. Hence, in simple harmonic motion, the time period of a body does not depend on energy E. A body of mass m is equal to 40 milligram attached with a spring of spring constant k is equal to 4 Newton per meter oscillates with the time period. Option A 4 pi seconds, option B 2 pi seconds, option C 0.4 pi seconds, option D 0.2 pi seconds. The key is 0.2 pi seconds. Therefore, the correct option is D. Reason. Formula for time period T is equal to 2 pi into square root m divided by k. Therefore, T is equal to 2 pi. M is equal to 0.04 and k is equal to 4. Therefore, 2 pi into square root 0.04 0.04 divided by 4, which is equal to 2 pi square root 0.01, and square root of 0.01 is zero point 0.1. Therefore, t is equal to 0.2 pi seconds. Hence, the time period is 0.2 pi seconds. A body, a mass M is equal to 40 milligrams attached with a spring constant K is equal to 4 Newton per meter, oscillates with frequency option A 5 divided by pi hertz, option B 5.5 divided by pi hertz, option C 6 divided by pi hertz, option D 6.5 divided by pi hertz. The key is 5 divided by pi hertz. Therefore, the correct option is A. Reason. Formula for the time period. T is equal to 2 pi into square root m divided by k. Therefore, T is equal to 2 pi 0.04 divided by 4 square root, which is equal to 2 pi into 0.01 square root, and 0.01 square root is equal to 0.1. Therefore, the t is equal to 0.2 pi seconds, and frequency is the reciprocal of the time period. Therefore, f is equal to 1 by 0.2 pi, which is equal to 10 by 2 pi, which is equal to 5 by pi hertz. Hence, the body oscillates with frequency 5 by pi hertz. In simple harmonic motion, the energy oscillates between kinetic energy and potential energy. If the frequency of oscillation is f, then what will be the frequency of oscillations of maximum kinetic energy? Option A, f, option B, 1 point f, option B, 2f, option D, 2.5 f. The key is 2f. Therefore, the correct option is C. Reason. At mean position, an oscillator has maximum kinetic energy. The oscillator crosses the mean position twice in one oscillation. Therefore, the frequency of maximum kinetic energy is twice the frequency of oscillator. Hence, the frequency of maximum kinetic energy is 2f. In simple harmonic motion, the energy oscillates between kinetic energy and potential energy. If the frequency of oscillation is f, then what will be the frequency of oscillations of maximum potential energy? A, f, option B 1.5f, option D 2f, option C 2.5f. The key is 2f. Therefore, the correct option is C. Reason. At extreme positions, an oscillator has maximum potential energy. The oscillator reaches the extreme positions twice in one oscillation. Therefore, the frequency of maximum potential energy is twice that of the frequency of oscillator. Hence, the frequency of maximum potential energy is 2f. In simple harmonic motion, the total energy of an oscillator is equal to kinetic energy plus potential energy. If the frequency of oscillator is f, then what will be the frequency of oscillation of total energy E? Option A 0 Hz, option B 10 Hz, option C 15 Hz, option D 20 Hz. The key is 0 Hz. Therefore, correct option is A. Reason. The total energy E of an oscillator remains constant, conserved at each and every point of its oscillation. Therefore, total energy E of an oscillator does not oscillate. Hence, the frequency of oscillations of E is 0 Hz. An oscillator oscillates about mean position, and at any instant an oscillator has the kinetic energy K is equal to 10 joule and potential energy U is equal to 5 joule. The total energy of oscillator at that instant will be option A 10 joule, option B 15 joule, option C 20 joule, option D 25 joule. The key is 15 joule. Therefore, correct option is B. Reason. The total energy of an oscillator at each and every point of its oscillation is the sum of kinetic energy and potential energy. Therefore, E is equal to kinetic energy plus potential energy equal to 10 plus 5, which is equal to 15 joule. Hence, the total energy of oscillator at any instant is 15 joule. An oscillator oscillates with total energy of 15 joule. If the kinetic energy of oscillator at any point is K is equal to 10 joule, then potential energy at that point will be option A 5 joule, option B 10 joule, option C 15 joule, option D 20 joule. The key is 5 joule. Therefore, the correct option is A. Reason. The total energy of an oscillator at each and every point of its oscillation is Et is equal to kinetic energy plus potential energy. Therefore, the potential energy is U is equal to total energy minus kinetic energy, which is equal to 15 minus 10, because kinetic energy is 10 and total energy is 15, which is equal to 5 joule. Hence, the potential energy is 5 joule.